Good evening, everyone. I'm Emmeline Joy C. Ramos, and for question number 1. So, an oil engine takes in air at 1.01 bar, 20 degrees Celsius, and the maximum cycle pressure is 69 bar. The compressor ratio is 18:1. Calculate the air standard thermal efficiency based on the dual combustion cycle, and assume that the heat added at a constant volume is equal to the heat added at a constant pressure. So, first, we must know on what are the different givens. So, we have the initial pressure, which is 1.01 bar. We have the initial temperature, which is 20 degrees Celsius. We have the final pressure, which is 69 bar. We have the compressor ratio, which is 18:1. We have the K constant, which is 0.4. And of course, the unknown is thermal efficiency. So first, let's convert degrees Celsius into degrees Kelvin. And we all know that in converting degrees Celsius into Kelvin, we're going to add 273.15 to the given value for degrees Celsius. Therefore, 20 plus 273.15 is equals to 293.15 degrees Kelvin. So next is for another unknown, which is T2. Oh no, let's solve for T2 to get the answer for in solving the efficiency. So let's use the formula T2 over T1 is equals to V1 over V2 raised to K minus 1. Or K, let's say K. So in here, this would become V1 over 2 raised to K times the temperature 1. Therefore, V1 over 2 is 18 times 0.4 times the initial temperature is 293.15 degrees Kelvin. Therefore, T2 is equals to 18 raised to 0.4 times 293.15. So we have here 3.1777 times 293.15 degrees Kelvin. Therefore, T2 is equals to, so let's solve answer times 293.15 here. So T2 is 931.5344 degrees Kelvin. Now, let's solve for P2. So, for P2, let's use the formula P2 over P1 is equals to V1 over V2 raised to K, wherein it would become P2 is equals to V1 over V2 raised to K times P1, wherein the value of V1 over V2 is 18 and the value of K is 0.4. And the value of the initial pressure is 1.01 bar. Therefore, P2 would become 18 raised to 0.4 times 1.01. Oh wait, I think it's 1.4. It's not 0.4. Let me check it. So this would become 18 1.4. Therefore, 18 raised to 1.4 here. it will become 57.7701 bar. And this is for P2. Next is for temperature 3. So, for T3. So, we're going to use the formula which is T3 is equals to P3 over P2 times the T2. So, where this came from? This formula came from the formula which is, or the equation which is P3 over P2 is equals to T3 over T2. Since P3 V3 T3 is equals to P2 V2 over T2 and V3 is equals to V2. Therefore, for T3, so we have here T3 is equals to, for P3, since P3, we have, since P3 is equals to P2, therefore P3 is equals to 69 bars over the P2, which is the unknown one, or the one we solve after before this, which is 57.7701 times the T2, or the temperature 2, which is 932.217 degrees Kelvin. Therefore, T3 is equal to 69 over 57.7701 times 293, times 932.217. So here, this is the answer for T3, which is 1113.4302 degrees Kelvin. And for T4, we're going to use the formula CV times T3 minus T2 is equals to C subs of P T4 minus T3. So, we have the CV of air, which is 0.718 kilojoule per kilogram. T3 is 1113.4302 degrees Kelvin, minus T2 is 932.217 degrees Kelvin, is equal to C subs of P of air, which is 1.005 kilojoule per kilogram degrees Kelvin. Okay. And then, the unknown, which is T4, minus the T3, which is 1113.4302 degrees Kelvin. Wherein, T4 is equal to, so let's solve it, 0.718 times 1113.4302 minus 932.217. Equation C subs of P is 1.005 times the unknown minus 1113.4302. So, T4 is equal to, there, 1242.8939 degrees Kelvin. Now, for volume ratio. So, for volume ratio, so we are going to use this equation, T3V3 over T3 is equals to P4V4 over T4, wherein is equals to V4 over V3 equals to T4 over T3, and it is equals to 1241.8992 degrees Kelvin over 1113.4302. There. Therefore, it is equal to 1.1159. So this, from this, we have the formula, which is V5 over V4, or the equation which is V5 over V4 over is equal to V1 over V4 is equal to V1 over V2 times V3 over V4, which is V1 over V2 is 18 and V3 over V4 is 1 over 1.1159. So here we're finding, or we're this is V4. So the answer for this is 18 times 1 over 1.1159. Yeah. Answer is 16.1305. Here. Next is 4.